Let's take a few minutes to think about all the various ways we can graph data sets in whatever software we're using. You might say, well, let's not get too software specific here in a math course, but what we're really talking about is data visualization and making sure we have accurate representations of the data that we have, which is pretty important in math. So here we have a data set from the pharmacokinetics field. So someone gave, a study gave a medicine to someone at time 0 and then measured the amount of that medicine in their bloodstream at various time points. Here's the time points they measured it at. I think this was ranitidine, if that's how you say it, which is a heartburn medication. So take a minute and think about which of these 4 plots, these are 4 plots you might reasonably make in Excel, which of them is more or less accurate for this data set, or even are some of them just totally unacceptable. So you might need to pause the video to do that and think about which of these graphs is more or less accurate or even acceptable or not acceptable. Okay, welcome back from pausing. Well, looking at these graphs, they all have the same basic shape, but this one seems a little bit more squeezed. That first peak seems a little bit more squeezed to the left than in the rest of these. And let's look at the x-axis. We know time is going from 0 to 12 here, but the first few steps are by 1/3 of an hour, and then a step for a half of an hour, half of an hour, half of an hour, half of an hour, 1 hour, 2 hours, 2 hours, 2 hours, 2 hours. So we want to see that the number line gets laid out the way that the data was taken. In the first graph, the x-axis is just 1, 2, 3, 4, 5 up to 13, which gives no indication at all of when the various time points were taken. The second 2 graphs do say when the various data points were taken, but the gap on the screen from 0 to 0.33, 1/3 of an hour, is the same visual size as the gap from 10 to 12, which is 2 hours. Same thing in both graphs. And then in the last graph, it does show that the data was taken from 0 to 12 hours, but it's showing that the gap from the first to the second data point is relatively small compared to the gap from the second to the last data point. So this last graph is the only acceptable one out of these 4 graphs. The others distort what happened in time. Also, what's going on with this first graph that reads 1 through 13, it's just reporting row number 1 of the data was this data point, row number 2 of the data was this data point. And it is actually showing the times in some sense, but it's showing them on the vertical axis and they're squished. So that doesn't really rescue the fact that it's distorting what the x-axis should be. So we might ask, how did we get these various graphs in Excel? I'll show you how the first one and this one got generated. The first one, if we highlight the data and go to Insert, and then this graph right here, it's called a line chart. So we'll choose that, and this is the one I used. So you can see that's basically the same thing. So the big problem with a line chart is it doesn't pay attention to the data you give it, hoping to make that the x-axis. It just counts 1, 2, 3, 4, 5, 6, etc. down the rows of the data set. These other 2 came from line graphs and various attempts to fix the x-axis. So we got the labels there, but they're not spaced the way they should be on a proper number line. And then this last graph here comes from highlighting the data and going to Insert, and then using the Scatterplot. And for some data sets, we want markers with no connectors. Here, I think connectors are helpful to visualize it. We hardly ever want smooth connectors, so I usually stay away from those. So these 3 usually, and I'm going to use this one. So that's the one we have over here. And so the overall answer is scatterplot is almost always, like 99-point-something% of the time, what we want to be using in Excel to graph a data set like this. There's also the issue of these graphs don't have x-axis and y-axis labels. Adding them would not have fixed this one or that one or that one, but I'll show real quick one way you can add them. If you click on this graph and then choose the Design tab, and then you can do Quick Layout, and choose a layout that has gray bars in the places you want axis labels. Then you can click on the axis label, come to the formula bar, hit equals, and then click on the cell that has the words you want in the axis title. And I'll do that for the y-axis as well. And then what should we use for the label? It's often good to say something about where we got the data from, so we can click on those. So that is a much better graph. And that's the big difference. Again, the big issue is the x-axis spaced the way a number line should be, and do the x-axis locations of the data match what's in our data set? What if you had a different data set, just to show that the distortion in shape is maybe moderate here, but if you had a different data set that was just y equals square root of x, what shape should that have, ignoring what these graphs say for now? Well, you might remember that y equals x squared is like a parabola. It is a parabola. Y equals square root of x is like a parabola turned on its side in just the upper half. So this is the graph, and that's a scatter plot that has that correct shape. These other graphs, which are line type graphs in Excel, even have the wrong shape entirely. So that's a pretty big problem with them. What if you know that your x-axis data is equally spaced? Is that okay? Then can I use a line graph? Well, let me just highlight this data set. I have some artificial stock price data here, and I'll insert, and I'll use a line graph. So is this a good representation of the data? Take a sec to think about it. Well, the problem is it's not showing us on the graph here what years the data came from. It kind of is showing us, but it's treating them as y values. So even if the data is equally spaced, you're not going to get proper labels on the x-axis if you use a line graph. You really should use a scatter plot. So I'll show that real quick. So every time we make a graph, we should think, did I get a graph that makes sense for what I wanted for this data? And then in the last sheet here, here's the kicker. This is basically the y equals square root of x data, but it has some missing values. Let's see what happens. I'm deliberately using a scatter plot here, which I know is the right thing to do, and we'll see what happens. Is that the graph we should have gotten? Take a sec to think about it. Well, the x values should go from 1 to 4096, and they don't. They just go basically 0 through 13. So it kind of did a scatter plot in that it looks more like the scatter plots on the other pages. It has the grid to it. But it, again, ignored the x-axis, the x data values we wanted, and just used 1, 2, 3, 4, 5 up to 13. So even if you tell it to use a scatter plot, you still have to stop and think, did it actually do what I wanted it to do? So that's kind of disappointing on Excel's part. We might wonder, is Google Sheets any better than Excel for this? So here's the same data in Google Sheets, and I'll highlight it and go to Insert and Chart, and it chooses a chart type automatically. So take a sec to think about whether this is a good chart for this data. Is its x-axis what we wanted it to be? I would say it's pretty good. It goes 0 through 12 hours, not 1 through 13 data points. And it seems to have data points spaced appropriately, as if with the bottom axis being a number line. The strange thing to point out here is, so this is what you get for a scatter chart in Google Sheets, which is okay. If I wanted them connected by straight lines, this is what it gave me originally. That's called a line chart, and it's doing something different than what a line chart had done that we saw in Excel. So even between the two programs, the terminology is different, and a line chart in Google Sheets is apparently doing the right thing. So overall, the lesson is, every time you make a graph, you have to look at the x-axis and y-axis and ask, is this making sense based on what I know about the data?